Hey, it's Mr. Shrum, and I am going to start Unit 2, Section 2 for anatomy, and that is the axial skeleton. Let's get into the lesson. Today, I think we're going to go over bone structure and maybe bone anatomy. Let's see how long these lessons are. But firstly, we're going to go over the structure of bones. The body is given form and structure by a framework of 206 bones called the skeletal system. In this system, you'll be learning about the major parts of the skeletal system, bone shapes, and special features of specific bone types. And the skeleton is divided into two major parts, the axial skeleton and the appendicular skeleton. Now, the axial skeleton includes the skull, the rib cage, and the vertebral column. So the skull up here, rib cage in your middle body, and then the vertebral column, your spine. And the appendicular skeleton includes the shoulder girdle, the pelvis, and limbs, your arms and legs. So shoulder girdle, pelvis, limbs. All right. Now, there are 5 types of bones: long bones, short bones, flat bones, irregular bones, and sesamoid bones. And we'll look at each of those right now. Long bones, like their name implies, are found in the limbs and are longer than they are wide. They grow more than any other bones during childhood and adolescence. The femur, fibula, tibia, and the humerus are some examples of long bones. Femur, fibula, tibia, humerus. Short bones are as long as they are wide, so they're almost squarish in shape, and provide support without much movement. Some examples of short bones are carpals, so bones in your wrist, and tarsals, bones in your ankles. Flat bones are thinner and flat, but they can vary greatly in shape. The ilium in the pelvis, the scapula, the shoulder blade, and the frontal, occipital, and parietal bones in the cranium are all flat bones. Irregular bones are uniquely shaped, and they don't really fit into any of those other 3 categories. Some examples are vertebrae, sacrum, and the zygomatic sphenoid and ethmoid bones of the skull. So they all have, they're kind of just doing their own thing. They're not really shaped like any other bone. Now we have sesamoid bones, and these grow inside of tendons that run across joints. 2 sesamoid bones are counted in the skeletal system: the patella, the kneecap, and the pisiform bone, small carpal bone in the wrist. Some people's bodies have extra sesamoid bones in the hands and feet. Fun fact, you may have more bones than other people. Surface features. In addition to shape and size, bones have many defining surface features such as cavities, projections, and slits. These features fall into three categories: articulating surfaces, non-articulating surfaces, depressions, and openings. Let's take a look at all of those. Bone articulations occur where two bones are joined together in a movable joint. Articulating surfaces are features on the bones that help them connect to other bones. They are necessary for stability of joints. Three main types of articulating surfaces are the condyle, a large round knob; facet, a flat shallow surface; head, a rounded end. Non-articulating surfaces are bony prominences that provide for the attachment of muscles and ligaments. So articulating surfaces are more bone to bone, and then these are more bone to other types of muscles or ligaments. For example, the pointy end of each vertebrae that you can feel as you rub your finger down your spine is a non-articulating surface called a process. Another example would be the iliac crest, which is the ridge along the top of the pelvic bone. Non-articulating features include process, crest, epicondyles, trochanters, tuberosities, and tubercles. Depressions and openings are indented, flattened, or open parts of the bone. These can be sites for muscle attachment or to accommodate other anatomical features such as nerves or blood vessels. Types of depressions and openings include alveolus, a socket, fissure, a slit; foramen, a hole; fossa, a flat, shallow surface; sinus, a cavity; and sulcus, a groove. The bones of the skeleton make up an inner framework that supports all other parts of the body. Bones protect some organs, such as the brain and the lungs, and they come in various shapes and sizes. Without the skeleton, the body would collapse. So that is the structure of bones. Now let's hide that and go back and start bone anatomy. So what's going on? Oh, zoom in. At the smaller level, human bones are made of specialized cells and protein fibers. Bones are hard, but they are not completely stiff and can bend slightly before breaking or snapping, especially in children. Bones are very strong. In fact, they are stronger than most plastics and metals. If bones are injured or damaged, they can repair themselves. Even though bones are very strong, they're not solid. They're mainly made up of osteocytes or mature bone cells. And it says, note, ost means bone. If you've heard of words like osteoporosis, that deals with bones and bone cells. Bones are held together in the skeleton by connective tissue and joints. Connective tissue includes cartilage, tendons, and ligaments. Bone tissue. Most bones are made up of two types of bone tissue: compact bone and spongy bone. The strongest part of the bone is called the compact bone. It's also known as cortical or dense bone. This outer layer of bone gives the smooth, white, solid appearance that we all are familiar with. It is made of calcium and minerals, and it's so dense that it must be cut with a saw during surgery. They even have a saw. It's called a bone saw. They use a bone saw to cut through bone if they need to. The building blocks of compact bones are osteons, which are rod-like cells bundled tightly together with tiny holes for nerves and blood vessels that supply nutrients and oxygen to the bone. Compact bone accounts for 80% of the total mass of the skeleton. And then you have this spongy bone, or cancellous bone. This part of the bone is much lighter in weight than that compact bone. And it's not really spongy, but it has a honeycomb look to it with tiny spaces. So I guess it appears kind of spongy. Red bone marrow can be found within the spaces of the spongy bone. Red bone marrow produces red blood cells, white blood cells, and platelets, or platelets. The production of blood cells is a process known as hematopoiesis, hematopoiesis. Yeah, all those unnecessary letters. At birth, all bones contain red bone marrow. As the body matures, some of the red bone marrow in the central cavities of long bones gradually changes to yellow bone marrow. So some of that red bone marrow that you start out with changes to a yellowish bone marrow. Now we're going to look at the components of long bones. Long bones also contain diaphysis, epiphysis, epiphyseal line, periosteum, endosteum, medullary cavity, yellow bone marrow. Here's a diagram. Let's see if we can zoom in even more. There you go. The shaft or long, slender portion of a bone in long bones is called the diaphysis. The end of a long bone is called the epiphysis and contains mainly spongy bone tissue. The epiphysis, I'm going to go with epiphysis. I think that's easier to say. Meets the bone shaft at the epiphyseal line. Most bone growth occurs at the epiphyseal line. When an adult stops growing, ossification or hardening of the epiphyseal line occurs. The periosteum is connective tissue that covers the entire bone except at the articulations where bones meet each other. This covering contains blood vessels that supply the bone with blood to keep it alive. At the center of the bone is the medullary cavity. This cavity is lined with a vascular connective tissue called endosteum. The medullary cavity houses yellow bone marrow. And that yellow bone marrow is full of fatty tissue and blood cells. It's mainly a storage tissue within the central cavity of long bones. So you see that? right there. Cartilage is a tough form of connective tissue. It protects bone ends and forms a cushion between your joints. Cartilage usually does not contain any vascular tissue, blood vessels, but receives oxygen and nutrients by diffusion. The entire skeleton originates from cartilage when in the womb. Cartilage is also found in places like the outer ear flap, the nose, and the knee. Bone strength. The strength of bones is determined primarily by the amount of stress put on them. Bone has the ability to alter its strength in response to the amount of stress placed upon it. When you exercise, you apply stress to the bone. Therefore, your body's response is to make the bone stronger by adding more bone. This thickening of the bone helps to prevent skeletal injuries and disorders. Thus, exercise is an important component in maintaining bone strength. So work out if you can, guys. Plenty of benefits. Now, if no stress is applied to the bone will become weak and thin because no new bone is being formed. This lack of stress on bones increases your risk for injuries and disorders. What was that about? Going into space, your bone density can actually decrease, and there may be bone loss, and that's why astronauts are encouraged to exercise or do some form of resistance training, because in gravity, there's even less pressure and stress applied to the bone. So you have to do even more work to make sure your body stays in top shape or as healthy as possible. But we'll get into the second part next time. So I hope that was helpful and see you guys later. Bye-bye.